This is the first of 2 Code With Me videos where I build a system that reads and processes data from a file. In this one, we'll use structs and typedefs and we'll parse the data. In the next one, we'll use that to fully parse the file. So in the long term, the file that I want to process looks like this. It is data about the size of your strawberry plants and the productivity of your strawberry plants. It has one reading every week through the growing season, and it has information about the height and the width of the plant, how many flowers it has, and how many fruit it has produced. And in weeks that it produces fruit, it gives you what is the average fruit size. So the long-term goal is to be able to read that file and to gather some statistics about it. For this part of the video, all we're going to do is try to parse one line of the file. So when I save that file as a comma-separated values file, it looks like this. The first row is that header row, but then there is a row for each reading, and it has the various things separated by commas. So what I want to be able to do is I want to be able to parse one of those and store the resulting data. So I have already created a struct that holds a date, the real values for the height and the width, and the integer values for the number of flowers and the number of fruits. And then I have an enum that is the average size of the fruit. It might be no size if there were no fruit that week, or small, medium, or large. And for the date, you see this date struct. Read that carefully. Struct, date declares a field whose name is date, whose type is struct, date struct. And up here, I declared struct, date struct to have a month, a day, and a year in it. So within the struct for my reading, there is a separate struct to hold the date, and then all of the rest of the data that is in the file. So from here to here, I declared a struct that had all of the fields that I wanted to have. I have embedded that declaration in a typedef statement that says typedef, all of this stuff, this name. So now I can declare a variable to be of type plant reading, and it will have in it all of these fields. So this typedef really just gives me a shortcut name for something. But so plant reading will be a struct that looks like this. My goal for this video is to be able to build this function that you give it a string that is a one line from that file, and it has an output parameter that is one of these plant readings. So it's a plant reading pointer that will have all of the data parsed into it, and it returns true or false. It returns true if we were able to parse the record correctly, and it returns false otherwise. So as an example of how I would hope to use that, I can make a char pointer. Oh, that's not good. That's not what I wanted. I wanted that. There is, as if I had read one row of the file. Row of the file will have a character return n at the end. So that would be the data from the file. What I would like to do is to be able to say parse reading data, put it into parsed data, which I better make the output parameter. What did I call that typedef? Oh my goodness. Brain freeze. Plant reading. What's a bloody name for it? Okay, so that's what I would like to be able to do. Get some data from the file, so get that, and then be able to pass that string into parse reading and have it put the things into the various fields of the output parameter that I'm giving it. So at the end, when it's finished, for example, result should be true, and current reading dot date dot month, for example, should be equal to 5. Oh, nope, should be equal to 6, because that's the month in the date that of the data that I'm currently parsing. That's what I would like to happen. Right now, I have declared that parse reading function, but I've just made it return false because I haven't built anything yet. If I run this, it will fail. It failed on the assert on line 10, and that's because I returned false instead of returning true. I can make it return true and get past that one, because I could say, well, I haven't had any errors, so I'll get past that one. And now month equals 6 has failed. So I have passed this into data. So here, my reading, I need to parse what's in that reading and put it into the parsed result struct. So I'd like to use that first thing is an integer. So I would like to use string to long to parse that. String to long, what it will do is it'll look at this. It'll start right, because I'm going to pass in data. It'll start there, and however many characters it can chew up to make an integer. So it'll go as far as it can to create that integer. It'll turn it into an integer, and then it'll also pass back to me a pointer to where it quit so that I can continue to parse from that point. So when I call it, I'm going to need and I'm going to do string to long, the reading, the address of the end pointer. And it also wants to know what base it should be thinking. And I want it thinking in decimal because all of those things are in decimal. Let's let it import this so that we get some error checking on it. And I want to store the result. It returns, it returns what I want. So in theory, that string to long is going to parse the first integer in the string, which is the month. So I'd like to put, chase parse result. Oh no, parsed result points to date dot month equals. All right, so we need, and now it's mad. That yellow squiggle is, I'm taking something that is a long, because string to long is returning a long, and I'm storing it into an int because month is an int. I know that it's never going to give me an integer big enough to worry about that, so I'm quite content to typecast it to the int. That'll be fine. But just for a moment, let's look at what this is doing. Parsed result is a pointer to a struct. So I'm chasing that pointer and then looking at the field date. And then inside that field, I'm looking at its field month. You can think of that arrow like it could have said chase parsed result. then look at the date, then look at the month. The arrow operator is the same as do that. It's just prettier and easier to think about. So I prefer the arrow operator. So it's going to take parse result, chase that pointer, so that'll chase it back to the current reading that was passed into it. And then in that current reading, it'll find the date field, and inside that date field, it'll find the month. And that's where it will store the strtol of the reading. So with that, then in my main, this should work. Woohoo! That's pretty slick. We can do that again. Then, oh wait, the next thing we want to parse is the day. And so this part is going to be right, but I'm going to need to think a little bit more. Hang on. Okay, now that looks like I totally cheated. Let's think again about what's happening. I'm going to comment that line out. Let's have it print out some stuff here. So, well, actually, let's put a breakpoint here and watch what things look like after we have done that string to long. So I'm sitting right here. My reading is this 614, yada, yada, yada. That was what was passed into me. My parsed result has in the date, it has a 6. All of the rest of this stuff in parse result is gobbledygook, was whatever was laying around in memory, because I didn't clean it out before it was sent here, because I'm going to trust that this function is going to write over every field in that. So it has written the 6 in the right place because it's in the date. And then if we look at end pointer is now pointing at /14, yada, yada, yada. And if you look, end pointer's address ends in 009, where reading's address ends in 008. So end pointer is pointing right at this slash. So string to long has been very nice to us. It has figured out what's the biggest int it could grab from the beginning of this and given that integer back to us. But then it has also given us a pointer to where it has finished. So in order to parse the next thing, I can start from end pointer. The next thing that I would like to parse is the 14, that is the day. But right now end pointer is pointing at that slash. So I want to just increment end pointer so that it will move off of the slash and onto the 1. So if I do that and I rerun this, now end pointer is sitting at the 1 and it is at 10, and so it's 2 positions away. So this plus plus moved it off of the slash. It's now pointing at the 1. That's exactly where I want it to be in order to do the strtol thing again. And this time I'm telling it start from end pointer and then move end pointer to the next place that you end. And where I'm going to take the integer that given me back and store it in the day. If I was going to write the test for that, current reading.date.day should be 14. That little error that you keep seeing there is because I am not using string.h. I should clean these things up. Let's see if I can have it not flash. That much better. Okay, my asserts worked. So I have successfully read the day. Just for thoroughness, I always like to check, look at stuff and make sure. So my parsed result now has in the date, the month, and the day. And end pointer is now sitting on the slash that's after the date, right before the year. Okay, so this is going very well. I'm good. So the next thing that I would hope for over here is that I could read the year. That's a funny 2025. And if I run that, it will fail. Yep, it failed. If I go over to here, I need to do the same thing that I did a second ago. I need to increment the end pointer to get it off of the slash. And then I can tell it to get to the next batch of things and store it in the year. Okay, I parsed the date. Woohoo! This is a good thing. Okay, so the next thing that we need to read is the height of the plant. And so we have left, we're sitting right on this comma. So the next thing that we need to do is deal with the height of this plant. So if we had done that, we should be able to assert that the current reading's height is 12.4. And that fails. Good. So over here, now instead of using string to long, the number that I'm looking for is not an integer, it's a decimal point. So I need to use string to d instead. I need to start by moving the current character off of the comma, and then our strtol point to height is string to d, passing in the current character and the address of the current character. So that's going to do the same kind of thing as string to long. It's going to grab as much data as many characters as it can to build something that is a real number. It's the real number that it finds, it's going to return, that we're going to store into height, and it's going to move current char to point to right where that number ended. If I run that, that worked. Now, to save us a little bit of time, now that we know how to do these things, I prepared for this. After the height comes the width and the number of flowers and the number of fruit. And we're going to do those the same way we have been doing these things, where so I moved the character, got the width using string to d, moved the pointer, got the number of flowers using string to long, moved the pointer, got the number of fruit using string to long. All of that should work. Woohoo! Okay, so now we have parsed all of these things and we're sitting right here on this comma, and we want to figure out this medium thing. So what ought to happen is fruit size is medium. That should fail because we didn't put any fruit size in there. Correct, it failed. Woohoo! Okay, so when I look at what I need to parse here, I'm kind of creeped out by this \n here. I don't have some magic string to long, string to thing, string to medium. It doesn't have that. So what I need to be able to do is I need to be able to look at that end string there and decide, is it medium or small or large? So the first thing I want to do is just get rid of that \n. We call that trimming the string. And the way that I'm going to do that, before we do any of this stuff, I'm going to get that \n off of there. And I'm going to do that by saying, I'm going to make myself a character pointer that is the end line, which is what that \n is. And I'm going to use the strchar function Strchar is how that is pronounced. Looking at my reading for a \n. And I know that there's a \n in there. If I didn't know there was a \n in there, or if I was worried about there might not be one, I would not use strchar. I would use strnchar to make sure that I didn't search way down into the hinterlands. But I know there's one there, so this is okay. So that's going to make endline be pointing right at that \n. And so then I'm going to say make the end line be the null terminator. Oh, chase end line and make it be the null terminator. There we go. So let's watch what that's doing just for good measure. So I come in and here's my reading and it has all the stuff and it has the \n at the end. When I step over, end line is pointing at the \n, and you can see this is 8 and that is 26 in hex. So it's really pointing right at that \n. So when I chase this pointer and I write the null terminator over the \n, that's just going to make the string shorter by 1. Ah, segmentation fault. I know why we did that. We have passed into here. See, this address is a 555555555. That's not our stack. You know, our stack pointer things all look like these 7F things. That is because this is a string literal. And string literals are stored in a section of memory that is not editable. So when we try to write that null terminator there, we get the seg fault because we're trying to edit something that is not editable. So to fix that, I'm going to make a copy of data that is local. So I'm going to allocate enough space. Yeah, there's nowhere near 100 characters. I'll be fine. And I'm going to copy into my data what's in data. So now my data, because I've declared it here, it's in my stack. That makes it totally editable. Copy all of the stuff over into it and then send it in to be parsed. Now let's watch what happens. I'm sitting here reading, looks like this, has the \n on it, and it has a pointer that I like much better. I step over, end line is pointing at the end of that. And when I step over this, you can see this just got shorter by 1 because we wrote a null terminator there. So now the rest of the time that I'm parsing things, I don't have to worry about that \n being there. It is not there anymore. Okay, so then down here, at the point where I have parsed numFruit, I'm sitting on the comma right before the medium. So I'm going to, once again, move that. And now cur character will be pointing at the medium. If not stir comp current character medium parsed result points to fruit size equals medium. And it thinks that's, oh, equals medium. There we go. Equals medium. That should be enough to make my test pass because the one that I was looking at had medium in it, and it did. But you and I both know that we need to do small and large as well. So now if I went over here and I made this, well, first of all, let's make sure medium still works. Medium still works. Small, small. That works. Large. Okay, so all those possibilities worked. The last possibility is there are some records. Where did it go? There are some records that don't have anything for fruit size. So if you don't have anything for fruit size, then this should be no size. And that's not going to work. Whoa, why did that work? That was a random lucky that it worked. There we go, it broke. So the reason it worked one time and then it didn't work other times, if we look at the enum, no size is 0. If we did not match medium, small, or large, we did not touch fruit size. So it has whatever was laying around in memory. One time we lucked out. There was a 0 laying around in memory, so it worked. But that isn't always going to work. And this time it did not work. So the question is, how do we know that it is no size? And the way that we know is because current char will be pointing exactly at the null terminator if there's nothing after that comma. So I can say if what's at current char equals the null terminator, parse result fruit size is no size. So if there's nothing there, we're already at the end of the string, then we get no size. And now that should pass. Yes, it does pass. Very good. But once I have this kind of if, I'm worried about the fact that maybe somebody typed in a value that was not correct. And in this case, if I don't do anything, if I don't match any of these ifs, then you'll get whatever was laying around. Maybe it'll be a 0 and it will be no size. Maybe it'll be a 1. Maybe it'll be 432. I have no idea what it would be. So if nothing has matched this, that means that I really wasn't able to parse the data. So I would really like, if we didn't match anything, we should return false. Because that means there's something wrong in the string. So like if you put something there, we should fail this, because since there's yuck here, parse reading should return false. This should be false. So if I run this and it fails on line 11, yay, it failed on line 11, it's false. Okay, so at this point, we have built parse reading, and it parses one row of the file and stores it into our data structure, our plant reading data structure. In the next video, I will build on top of this to build something that actually does the reading from the file, and uses this to parse the data and gathers some little statistics about it. Hope to see you there. Thanks. Bye.